Hello and welcome to the first of our web series for educators. Today we're going to be focusing on 3D printing to improve learning outcomes. I'm your host, Evan Spitler from SparkFun Electronics, and joining me,
Megan from Lulzbot.
And we're going to cover a couple different things to show you how you can use 3D printing in the classroom. Mainly we're going to focus on a little bit of 3D design. If you don't want to design, we can show you where to get files that you don't have to design. We'll show you a few actual applications for 3D printing in the classroom. But first I want to start by showing you how easy it is to get started with a 3D print. So I'm going to start with the first thing that you want to do when you get your printer set up is preheat it. We've already got it to the temperature we want. There are a series of profiles available for each different filament that we're using. Today we're going to be using ABS. It's one of the most common filaments available. Also there are others such as PLA and high impact polystyrene, which can be used just as well. So now that we're already at temperature, I can show you the direct SD card user interface. All you have to do is punch the button here, print from SD. Hold on, let that come in back into focus. All right, print from SD, and then you want to find your specific file. I have this fairly buried down in here. Oh, back up. And then once you tell it to go, it's pretty walk-away autonomous. Since this has already been at temperature for a little while, it has collected a little bit of plastic discharge. You can just pull that off with your tweezers and it'll be fine. A common problem that you might find is that the filament does like to stay with it does like to attach to a hot nozzle almost as much as it likes to stick to the batter itself. So it's not necessary, but it's good practice to keep that clear so that it doesn't bind and turn what an otherwise ordinary print into spaghetti. So yeah, as that's going, as I said, there are a couple of different profiles available, both in temperature and in G-code settings, and I'll get into that in a little bit. And each different one covers a different material. PLA, it's a polylactic acid, that's a corn-based plastic. ABS, which I said is the most common, that is a acrylonitrile butadiene styrene. It's a very common industrial plastic used in basically every consumer electronic ever made, at least in modern history. High impact polystyrene and many others to be sure. For ABS, I like to set the nozzle to 240 degrees Celsius and the bed to 115. And ideally that will give you good bed adhesion if it's leveled. Okay, cool. Looks like we are sticking. So we're going to let that just do its thing and it'll chill in the background. So yeah, now that we've got started, I'll show you a little bit about what's going on here. The procedure is basically find your model or make your model, prepare the model for slicing, and there's software available to do that, and I'll show you that as well. Locate and orient the part on the bed, and then once you're satisfied with that, get the printer up to temperature, determine the settings that you want to use, and that's where you can load pre-existing profiles, and then load the G-code into the printer and tell it to go. So, as I was saying, there's multiple print profiles I can show you in Cura here. And Cura is the software that I use to take the existing model and cut it into a series of instructions that the printer will recognize. And you'll notice that this is not the same model that's going on in the print window. That's fine. What I want to show you here is things like layer height, shell thickness, fill density, and as well as nozzle size and bottom layer speed here. So it's currently set to standard. So layer height, that's pretty much the most common way you can control your resolution. This is currently set to 0.25 millimeters. You can set it down to anything down to like 0.06 millimeters. This one will be able to handle all right. And what that does is it just determines the different layer heights or the different vertical resolution. The horizontal resolution is sort of defined by the nozzle size itself. Because the horizontal planes are effectively a vector, the nozzle size itself is the limiting factor. Any other shapes that are larger than that nozzle size can be pretty well replicated. So a little bit into 3D design. I kind of touched on that a little bit. The way that these models are built, it's just a 2D plane that it lays down on the bed, and then once it's done with that first plane, then it lays the next plane, and then the next plane, the next plane. And what you end up with is a stack of planes which have their varying shapes, making your 3D object. So there are a couple different ways to attack that 3D model building idea. The most common is the extruded cut, or the extrude or the cut, which is basically taking that profile that you draw and extending it into the third dimension. Another way to go about that is if you take that 2D object and you revolve it around an axis, you can make round objects like drive shafts, axles, things like that. Another way that you can do that is a draft, which takes one 2D shape and a different 2D shape at a different height, and it blends those two into one another, creating a blend or a draft. And that's good for designing like adapters for ventilation, where you have a square that needs to go to a round, or anything where you need to change the profile shape throughout. Now, the design for printing, it's a little bit different than other rapid prototypings because printing is an additive technology. All that means is it changes the shape of the piece you're working on by adding material rather than taking away. So because of that stack and because of the add, you end up not being able to print certain shapes. You need to watch out for overhangs and things like that. Otherwise, you could end up with a compromised piece. There's a really tiny, I think it's Smokey the Bear here, but we got a close-up on Smokey. He had an arm sticking out, but there was no support material underneath it. So it ended up, I just broke his leg off. It ended up kind of not having a really great definition on that arm. So one way to combat that is to design your objects so that they don't have that much overhang, but sometimes you just can't help it, so it's helpful to add build-up material. And fortunately, the Cura software does have a toggle, a setting that you can change your platform support type, and that will build up a non-critical structure that just supports the object, and then when the print is done, you can peel that away fairly easily. And so there are a couple of different programs you can use to to design your 3D objects, depending on where you are on the free to not free scale. Some free options would be like FreeCAD or Blender. However, if your school has a subscription to or a license to one of the more sophisticated CAD programs such as SolidWorks or Creo, those will also port fairly easily to create a 3D shape that you can print. Other options such as SketchUp, or really anything where you can output a STL or OBJ, and there's a few other formats such as DAE and AMF that you can also port to the printer, and it'll recognize it and be able to generate that geometry. If you're not into drawing your own, designs, there are a few places that you can go where you can basically just download an already existing and already refined model that you can just drop into the printer and go. One of the most common that people like to use for downloading 3D objects is Thingiverse, but there are other repositories available. For instance, SparkFun itself, we have some of our own models, or we have models of some of our own products, and we make available the STL and also the source SolidWorks and Blender files. So if you want to print something from our catalog directly, that's also an option.
And then Lulzbot also puts out their 3D models for all of the printed parts that are on our printers. So those are available too. And
so, like SparkFun and Lulzbot, there are some specialized repositories. Like, for instance, NASA has a good example. They make some of the 3D models of their spaceships. Particularly, the one that comes to mind is the New Horizons spacecraft. For the Pluto flyby last year, we printed one up just so we could have a good visual model of it.
And there are also museums, several different outlets that put out repositories of models depending on what they do, what their specialty is. They'll put out models that go with that.
Right on, thank you. So there are a wide variety of applications that one could use a 3D printer for in the education field. And it could be tempting to say, well, why would we get this thing that's just going to be used to print a bunch of junk and toys? Well, there are definitely some useful applications. The first application that comes to mind is definitely in the more STEM-oriented fields, like engineering, robotics, mechanics. Like, you can make from scratch, from your gray matter, a robot that'll work. And it looks like we have a question from the internet audience.
Which software are you using?
So for the printing itself, we use a software slicer called Cura, which is available from the Lulzbot site.
There's a Lulzbot edition of Cura that we work through, and we load profiles that we've tested specifically on our Lulzbot printers and built with the different filaments that we sell in our store.
So that's only one part of the whole idea to thing tool chain. So if you go from your inception of your idea, you want to have a way to capture that. And the drawing softwares that I just mentioned, I frequently use SolidWorks here. That's what I license. I found myself working a lot with Fusion 360 a lot lately. FreeCAD is a nice open source and no cost full-featured CAD program. And then there's things like Blender and SketchUp that are also available to use for free. And then once you port your model to an STL, you load it into Cura, and it drops it right into an instruction that the printer will understand. So, as I was saying, in the STEM fields, there are a wide variety of things that you can do to show off engineering principles, mathematical concepts, anatomy. Like, here's a good example, human skull. This was taken from a medical compositing website, and all I had to do was download the 3D model and drop it into Cura and print it. And this probably represents about 48 hours of print time, but it also, because of the overhangs and the dome features, it used up a lot of that was in build-up support, so the print wouldn't collapse during the during the printing process. Also, the person who loaded this to the repository had the decency to cut the skull into strategic places so that it would have a good flat surface on the bed to marry up with the bed, so it had great adhesion. And that's another problem that comes up with 3D printing, is if your part doesn't adhere well to the bed, it can lift and ruin the print. And I'll get into a little bit more on that on troubleshooting later on. I just did want to show you that. Another good STEM application, if you're into electronics, like we at SparkFun are very much, you can use these to print enclosures for some of your electronic components. Right here I have my little friend BMO from Adventure Time, and this is a functioning video game controller, again, that I downloaded off of Thingiverse. But the design here was made, it's basically an enclosure for a Raspberry Pi, game controller, and an LCD screen with audio amplifier and speakers inside. So, and yeah, I chose to use that as just a toy, but there are definitely ways to wrap engineering and more scientific curricula around that. Now, outside of STEM, there are also applications. I mean, this can seem all very high-tech, and it is. And it's worth talking about the technology if that's what you want to focus on. But it isn't always about the technology. You can make things that don't necessarily revolve around science. For instance, if you have a theater program, you can make props and do set design. For history, you can make mock-ups, ancient castles, world landmarks, things like that. Personal favorite of mine is making actual functioning siege engines, so you can wage desk warfare with your colleagues. And additionally, like for literature, if you want to task your students with making dioramas from the book that you have them reading, let's see. And one other example is this is a design a friend of mine tasked me with. He wanted me to make a music stand phone that mounted to his musical instrument. He plays trombone, and I don't really have a trombone, so I just did a mock-up with a PVC pipe. But this is it's basically just an iPhone case with a clamp that I made that would clamp onto the tube. So, you know, if you play trombone, and you can see the sheet music as it's laid out on your personal device.
And some of my favorite uses are creating learning tools, letters, alphabets, numbers, counting projects that help kind of put those into place. Those are really good for elementary early learning. And then really there's just endless opportunities to enhance curriculum using 3D printer. You can do anything with it, and so you can create anything and you can make it work for you.
And it's such a great, amazing opportunity because you can, as Megan said, create anything. Like, there are some limits on the geometry, but really anything that your mind can conceive can be made. And additionally, beyond just teaching aids and STEM curriculum things, you can also make handy little things for classroom, like racks and brackets, and anything that breaks, you might be able to model and fix a replacement part for it and save a little bit of...
Including your own printer.
Including your own printer. Fortunately, because Lulzbot is so aggressively open source, they make the files available. As you can see, if you want to take a look at the printer itself, all of the red that you see has been printed on this printer for this printer. So there's a little bit of self-replicating technology. In fact, the Lulzbot itself was born out of the RepRap project. Was designed to make something that can make itself, and
There are about 40 printed parts on our TAS models, about 29 printed parts on our Mini. So they make themselves. We have a cluster of printers that print parts for printers. It's something to see for sure.
And it's definitely wise once you have your printer to make some of the parts, because as things do when you use them, entropy increases, things break. So it's nice to have a replacement part already staged and ready to go for when something does fail. So that brings me to the next section of troubleshooting. So there can be a lot of problems that do occur. These are highly refined pieces of equipment, but they do still take a little bit of love and attention to operate. So some of the common problems that I encounter, sometimes the parts will curl a little bit in the corners, and a lot of the lifting, curling, and separating is frequently due to temperature control problems. So it's wise to keep your printer installed in a very temperature controlled environment where there aren't a lot of drafts. And sometimes that's not necessarily an option. So it might be advisable to make an enclosure for it. I've made for both this version and for my home version, which I have a personal printer. I've made plywood enclosures. It's just a box that goes around it, keeps the drafts out, keeps the cats out. It's great.
And Lulzbot actually carries an enclosure as well that is not plywood.
So if you want something a little bit more refined, a little less homemade looking, you can also get your solution ready-made from Lulzbot. Another way to mitigate the lifting and curling problem is in Cura there is a setting to increase your brim size, or to actually have a brim included. So on the basic tab, under platform adhesion, you can tell it to have a brim or a raft. And a brim is basically just an outline that goes all the way to the edge of the part. And what it does is it gives the part more surface area, so it's less likely to pull up and lift during the print process. Another problem that can occur with temperature effects is the separation of layers, delamination. So this is one that I had a problem with a while ago, and this one I was fine with putting this into action just as it was, but you can see right here is a big lift right here because I didn't quite have my drafts perfectly dialed in. So there was a little bit of cool air that caused this to warp, and it just separated away. So a way to get around that is, again, keep the enclosure and keep your environment fairly controlled.
There are also different filaments that work better in different environments. So there are ones that are more affected by temperature.
Sure. ABS, as common as it is, it is very temperamental when it comes to cooling, and so maybe you want to go with something like PLA, which is very dimensionally stable, or the high impact polystyrene.
Some of the copolyesters as well. We carry a couple that are specifically made to take care of some of those issues that tend to happen. NGen, Innova 1800 are both really good copolyesters that kind of alleviate some of those issues.
Another advantage to those engineering copolymers is they have really great impact strength.
Yeah.
So if you're clumsy and you tend to drop things, you have a better chance of survival of your piece. So another problem that we can run into is with bed adhesion. Sometimes, like I said, with the curling, sometimes pieces lift. Sometimes a part will lift off the bed altogether, and it'll just grab onto the nozzle, and then it makes a mess. Your part doesn't come out. That's no good. Temperatures, the bed temperature is a good way to keep that controlled. For ABS, the Lulzbot recommended temperature is usually around 110. I like to go 115. That's a little bit hotter and it stays on the bed. All right. In addition to controlling your bed temperature, there are some things that you can also do. For instance, keeping the bed clean and clear, free of oils in your hands. If you want to clean off the bed every now and again with a isopropyl alcohol solution, like a 90% water to 10% isopropyl is probably a good mild detergent to clean off your bed. And if you're really having problems with bed adhesion, you can also throw on some really fine, like 2000 grit sandpaper, and just give the PEI surface a little bit of a
Conditioning.
Thank you. Another issue that can come up is binding. So when you open your roll of filament, you have the loose end. Sometimes when it's not well contained, it can just be loose, and sometimes it'll tuck under some other loose strands. And if you don't catch it, what it ends up doing is it'll tie a knot in the spool, and eventually that knot will get so tight that the extruder will no longer be able to pull filament through, and it basically, it's like running out of filament, but there's still plenty left. So you want to make, once you have your spool open, you want to keep careful eye on your loose end to make sure that it doesn't slip under. Similarly, it's very easy to run out of filament if you're not paying attention, especially if you're running a larger print. Typically spools come in 1 kilogram or 500 gram rolls. So one way to make sure that you have enough is you can weigh how much is physically on your roll still, and Cura, in its infinite wisdom, can sometimes, when you have your part loaded, it will give you an estimate of how long it thinks the print will take, how many linear meters of filament it will take, and how much mass of filament. And these estimates can be subject to different factors, and thus may or may not necessarily be accurate. But it will at least give you a really good idea of how much filament it will take, and you can plan accordingly. It's like, oh, this is going to be a 45 gram thing. I only have 30 grams left on here, and maybe the fudge factor will allow that print to happen. But again, you might end up with exposed infill when you run out.
Yeah, you definitely don't want to start a big 20-hour print with a 500 gram rail.
Definitely not. In fact, some of the tools that I've made for our operations department have turned out to be bigger than these really cheap rolls that I've been buying. It's like, okay, I need to get a proper 1 kilogram roll if I want this print to not fail on me. There is some theoretical development with trying to merge an exhausted spool. I've experimented with it a little bit, and I've got it to succeed once or twice. It's not necessarily recommended, but if you're into exploring, I mean, maybe that's a challenge you want to take on. So other problems that you can run into, particularly loss of connection. If I pulled my USB cable out right now, the print would just stop where it is, and I probably couldn't recover it. So you want to make sure that that you have a secure connection, that your computer is not going to go to sleep in the middle of your print, and that it's not going to get unplugged by some curious hand. Conversely, you can leave your computer completely unattached to the system and just run on the SD card, which this program is currently doing. The different models have the SD cards in different places. The Taz 4 here has it on the side, but this is running almost completely headless. I only have it connected to the printer for demonstration purposes, but you can operate here as I did at the beginning of the presentation and control the printer and the G-code from there. And that does definitely help mitigate. Also, if you do have a lot of people using the printer, the headless mode might be a better way to go, just because you don't want to necessarily tie up one computer to a print, especially when the print can take 2, 4, 20, 30 hours to make.
And when you have students who are designing their models, it's nice to have them on SD cards, because then they can each do their own design, load it on their SD card, have all their designs on one SD card, and put it into the printer as it's their turn to print.
And also, having the students have their own SD cards is advantageous, because then they own all of their files. And because the SD cards are so compact, they can load it onto a school computer or something, so they have however many copies of it, so it doesn't get lost forever, because SD cards can be small and get lost fairly easy. Another problem that one could run into is loss of power. If you have a power failure in the middle of your print, there's, again, not much you can do to recover it. So sometimes if that's a major concern for you, you could probably run your printer on an uninterrupted power supply, or just make sure it's not on a time-sensitive or timered switch. So yeah, you don't want to lose power. You want to make sure that you mitigate anything around your power solution. Another problem that you can run into is mechanical jamming. This one's fairly rare, but if you have an object or a print even that prevents the X or Y axis from actually moving, that can ruin a print just as well, and that can also cause damage to the printer itself. I've really only had a problem with that once in 3 years of running this particular machine, and it was just a stray piece of cardboard that I was using to block drafts before I built the plywood walls, and it just became dislodged and prevented the X axis from moving. I was a little upset with it because I was a larger print, but I learned from it and I was able to mitigate it in the future, which is now the past. And actually, speaking of damage to the printer parts, another problem, this is the rarest and the last problem that I'm going to talk about troubleshooting for, is failure of electrical components. Now, inside that box is just another circuit board, and it's subject to all of the woes of what electronics can be subjected to. So I had a backdriving problem, and it actually overloaded the stepper circuit on the controller board. Now, if I wasn't me, that could have been a problem, but because because I work in a place that is not effectively, it really very much is an electronics factory, I had access to a few tools and a little bit of expertise that I was able to simply pull the board out, disconnect it from the printer, and do a little bit of electronic surgery, as it were. So all of the board, all of the parts can be just, with a little bit of hot air, removed and replaced. And fortunately, because the parts are open source, the schematics were readily available. I could look into, it's like, okay, here's the exact stepper motor driver chip that I need to order, get that part, look at the diagram, look at where it needs to go, remove the old part, replace it with a good part, and still seems to work, so I'm happy with that. It was actually good that I did that, because when I made this version of that printer head, I also back drove the extruder motor, and that ended up killing that, so I literally killed two birds with one stone, or killed two stones with one. The analogy is lost, but because the schematics are readily available, if you know a little bit about electronics, you can perform your own repairs, and it'll work good as new. So,
Looks like we have questions.
okay, we have questions.
Can you repeat the percentage of isopropyl solution?
Okay, so the isopropyl to water solution, it was 90% water, and that was just regular tap water is fine, and 10% isopropyl alcohol. Now, I like to use a 90 or higher as far as which alcohol to use. So like a 73% medicinal alcohol might leave some residue. Even a 93% could leave a little residue, but that's 100% isopropyl alcohol is more of an industrial thing, so it's probably less available. So getting the 93 or the 91 or whatever the higher percentage that you can get in the supermarket, that's probably fine. And then just water that down, 90% water, 10% alcohol.
Put it in a spray bottle. Make sure your electronics are off.
Very good advice. And what was the other question?
The second one, is it possible to get such high quality prints from a replicator VFAC?
I can't really speak to the MakerBot models. The last MakerBot that we had in-house was a Thing-O-Matic, which was very early technology. I found that with a Lulzbot, I get better resolution, better quality prints now than I did with the Dimension machine that I had access to in college back in 2009. But I can't really speak to the other brands and the other makes. I've only played with this one and the version and the rep that I made. So. So another great application, I think, as far as either anatomy or in art, sort of going back to the whole educational applications, is anatomical models. I've got my friend Dexter here, and this was designed by a fellow in Blender. And the model has about 70 points of articulation right down to the fingers. And so this is a good example. You can use this in science or in health curriculums to show, human anatomy and how they bend. But that also translates into art. So you can show proportionality, muscle tone, and human kinematics.
Drawing models.
Drawing models. And if you're really feeling froggy, if you wanted to practice a little bit of stop motion animation, something like that, you could use this guy for what would effectively be sort of a film schoolish application. But yeah, there's a wide variety of things that you can do for demonstrating and for actually for engaging and making these sort of grabbing the attention of young ones. So now that the print has finished, it's definitely advisable to let this cool down. The recommended release for ABS is about 40 degrees Celsius. If you're impatient, you can pry it off of there with the included oyster shucking knife. But doing that can be a little traumatic to the PEI print surface. So it's best to just let it cool off, let it be for a while, and then once it gets down below 40 degrees, you can just peel the part off. Now, PEI is wonderful, magical stuff, and it does great for adhering to the part when it's hot, and then once it cools down, just letting it go. Sometimes larger footprint items will be a little more reluctant to let go, and in that case, that's when you might want to pry things off. But if you get a little too aggressive, you could risk damaging the PEI surface. And there are a couple of other surface treatments that you can use with these printers. So if you damage your PEI surface, actually Lulzbot has a really good tutorial that they just released about how to replace your PEI surface. And if you can see the close-up, I'm starting to get a little bit of that bubbling on my own bed here. So when I get a minute, I'll see that right here, the lighter spots, that's where it's lifting away from the bed. So when I get around to it, it'll be, I'll definitely want to replace that film. But there are some other options as far as what you can use as a print surface. Now, bare glass is usable, however, not recommended, and as much as I like to say I avoid warranties, the printing on a bare glass surface will void your warranty, and it will, not if, it will chip the bed eventually. Even if you use surface treatments such as acetone with ABS dissolved into it, or glue stick. Yeah, just regular stick of glue. You might want to have something in between that and the glass. Now, I try to discourage using any other treatment when I have a good PEI surface, just to prolong the life of that surface as much as I can. But if that's not an option for you, you can also use things like blue painter's tape or even masking tape. Some of the older rep users would use Kapton or electronics tape, basically. So some of the other surface. Write that down. There are other plastics as well, like the PET film that these used to come
PET
with.
tape.
Yeah, I actually, on one of my first prints, when this was still just a lowly TAS 4, it had the PET tape film, and I wasn't too terribly cautious about it, so I got in there with, I wanted to peel off my print, and I got in there with a straight razor and just marred that up. And that's actually how I learned that the bare glass will eventually chip. Because, I guess I don't need this. The bare glass is fine. I printed on that for a little while, and then it chipped. And then I'm like, okay, well, I'm a jerk. And then I found out that our tech support team had done the same thing, and I think our marketing team with their printer had done the same thing with their bed. So I'm like, okay, no bare glass. Fortunately, if you do need to get a replacement sheet for PEI, it is available on the Lulzbot store.
Yep, it's an easy replacement, an easy fix. Another question?
If it's a heated bed, do you want to use tape or film or anything else?
So with the heated bed, as all of the TAS and all of the Lulzbot minis are, the PEI film that is supplied is ideal. I don't recommend adding any additional tape or solutions or any other surface treatment unless the bed has been compromised in some way. And even then, I only recommend that as a temporary measure until you can
get your PEI sheet replaced.
Exactly. So yeah, the main takeaways that I want you guys to get from this is that 3D printing technology has become massively, massively accessible. And even if it's not necessarily a Lulzbot printer, there are a whole zoo of 3D printers available out there, differing price points depending on what your budget can support. Now, these can be a little costly, but these printers are quality machines. I have put probably thousands of hours and definitely a few kilograms of filament through this very machine, and it has treated me well. It does take a little bit of love, it does take a little bit of attention, but if you take care of your machine, it'll take care of you.
Absolutely.
Another thing that I wanted to point out is that there are a wide variety of applications in the education field, both directly as far as the curriculum is concerned and indirectly, just things that you can make to make your lives better. And that printable objects can be found using a wide variety of sources, from repositories online to drafting your own designs from your own mind.
Yep. The possibilities are endless.
Exactly. So let's see, it's still at 75 degrees Celsius, so it's still a little hot to remove, so I'm going to leave that be for a minute. But I definitely want to encourage you, if you still have any other questions, get them on in. We'll be happy to answer them. Some other things that are worth pointing out. Getting your settings dialed in as precisely as you can will make the best possible quality print. Now, with the profiles that are available, you can get some generic settings, which will work, especially if you're just doing one-off prototyping or demonstrations. These generic settings will be fine, but as Lulzbot makes a lot of their own parts, it's in their best interests to reduce the need for secondary handling. So in that, they like to get their settings and their G-code dialed in to as close to their exact spool of filament and their exact part, because making a part with a rough edge might not necessarily work if you're going to try and sell it. If it's just a demonstration, it's probably okay, but there are ways to mitigate that as well. For one, getting your temperature settings dialed into that exact filament. Maybe the filament that I'm using doesn't want it to be at 240 degrees. Maybe it wants to be at 238 degrees. It's little tweaks. Your mileage may vary. Another thing that you can do to make sure that the G-code and the physical material agree most is to make sure that your filament diameter is dialed in, because these are typically sold in thicknesses of like 1.75 millimeter or 3 millimeter nominally. Oftentimes, the filament that you get will range between, say, if you're getting a 3 millimeter filament, you might have 2.88 or 2.91 millimeters, and that tiny variance can actually have a huge effect on the finish of your print. So having that dialed in to what the filament actually is can make better quality prints. And again, like the printer bed, I've discovered through experimentation and running that a generic 115 degrees has worked historically for me over the recommended 110 degrees. And again, per different filament and different materials, those temperatures will vary. For instance, okay, so ABS is like 110 and 240. A PLA might prefer its bed at like 60 to 80 degrees Celsius, and a filament temperature, a nozzle temperature of 180 to 200 degrees Celsius. So there's like so you can use the profiles to as a starting point, but these are all just recommendations.
Yeah, I like to, when I'm starting with a new filament, I like to run a small test print before I start something big like the skull. I'm not going to start off a brand new reel of filament with a big print. I'll do something little to make sure that everything's dialed in.
And that's definitely a wise practice. This was probably the third thing that I printed on my home printer, and so I sort of just jumped in with both feet. And if you look closely at it, you can see some of the cracks and delaminations. You can see where the filament got too hot and it burned, and it makes these really interesting striation lines. If I'd probably been a little bit more cautious with the filament and with the settings, this might have been an even higher quality print. But even with my sloppy settings, this still came out really well.
Yes, it's very nice print.
So yeah, unless there are any other questions, I think that's about all that we have for today. But just remember, you can make just about anything you want within reason. There are some limitations, but for the most part, it's a very unlimited tool.
Yes.
And it is definitely, while it is a powerful tool, it is not an end-all be-all solution. It can wrap in very nicely with other rapid prototyping technologies. As desktop CNC becomes more available, it's one voice and a chorus. But as you start to understand these technologies, and as you get access to more of them, you see that they're not so different, in that it's a machine, it takes instructions, and the biggest drawback is it does exactly what you tell it to. So thank you for joining this first installment in our webinar series. I've been Evan Spitler.
Megan?
and happy printing.